Hello, it's me, and as you can see, I brought this puzzle out. I dusted it off and blew the smoke off of it. This is the Earth Crazy 3x3 Plus puzzle. You know, when looking back at the previous tutorials, this was in the early years of doing these videos, and when I originally did them, I had a couple of constraints. First off, this was before the whole YouTube partnership limitless minutes came, so I was limited in terms of how much time I could use, and I didn't really want to have it in several parts. So really the tutorials at first were geared for people who probably had a pretty good degree of expertise on these puzzles, but just to help kind of guide through them. But to those who weren't used to solving it, it could be pretty confusing, and when reviewing it, there's a lot of stops and starts and speeding things through, and I knew what I was doing at the time. I was just trying to get a general overview of it, but I was trying to squeeze it all in at once. So now that I don't need to worry about that stuff, I've had some requests to do a couple of reboots of some of them, one of which I already did, which was the Saturn cube. I've had some more looks at the Earth cube. So I'm going to do the Earth cube again, but I'm going to go ahead and do it slowly and kind of go a little bit more descriptive on exactly what strategies that I'm doing. Also, I'm not going to assume any knowledge of any of the other puzzles. This is in case you happen to pick up the Earth puzzle, you don't know anything about the Mercury, the Saturn, the Venus, or all the rest, you just want to do the Earth. Now, as a result, if there's any further requests of other earlier tutorials that you'd like me to reboot or redo, especially because they were at the time when I had time restrictions and things like that, let me know and I'm happy to do that. So let's go ahead and do another look at the Earth cube and see how this comes together. And I'll just kind of slowly go through my strategy with this. Now the color scheme of yours may be a little bit different, but what separates this from a normal circle cube is the fact that you've got parts that turn, you've got fixed centers. I'm going to call these fixed. I'm not going to say bandaged or unbandaged because that was confusing even to me. But anyway, so these are all fixed centers over here. And then you have non-fixed centers over here. So you see this turns along with the side, and you have another side that does that too, which is here. So the whole aspect of the Earth cube is that you have two right next to each other that are non-fixed. This one and this one, which makes for interesting scrambles because if I move this over to here, it's fixed, but then when I move it here, it becomes non-fixed. So what separates this from actually a regular circle cube? Well, what I have here, it says Mercury, but it's actually not really a Mercury. This is a full circle cube. This is something I modded a long time ago because really I wanted a full circle cube as it was something to help complete the series. So what makes it different is the fact that there's a certain degree of limitations that you have with the scramble of this puzzle that you don't get with this. So what I'm going to do is I'm going to use this to help demonstrate the solve of this to go through maybe some of the sticky points. But here's the limitation of the scramble that makes this easy to solve. If I were to scramble this up over here, turn, 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 you find that all of these are pretty much stationary. So when I'm turning these things, these inner edges are kind of limited with their scramble. In other words, these edges here never leave this orbit. There's nothing I can do to make them leave that orbit, no matter how I turn them. But that's not the only association that happens here. It also turns out that because this, and this are fairly restricted with where they're supposed to be, this little triangular centerpiece here is bonded with this one over here. It never leaves this one's sight. So basically what you're not scrambling is you're not scrambling these pieces in relation to each other, these inner edge pieces, nor are you scrambling the squares, the triangles here in relation to the edges over here. No matter where I move this edge, this piece always follows it. So because of that, I've limited my scramble, and each edge has an inner corner piece that follows it too. So in reality, the scramble of this is pretty limited. What this means is that these pieces actually can represent just as much center pieces as they represent edge pieces. These are really the true edges over here. They articulate between two centers and they move around with each move of the face. These don't. They act like quasi-edges when you move it like this, but they're actually acting more like centerpieces. So if you look at it like that, the first step would be to place the centerpieces. And the first step with doing a circle cube solve would be to do what I guess would amount to center reduction. And really, when you think about it, here's the green center. All the other centers, all the other inner edges, which can be thought of as centerpieces, are going to be positioned. I don't even have to look. I know that they're there. So it's really more placement than anything else. Place this over here and bang, you've got it. So that's generally the first step that you do with most circle variations, but really when you look at this, these edges have now become pretty much centers. Well, these are the true edges. So the rest of the solve is pretty much doing like a supercube solve, that every time you make a turn, you're going to knock a centerpiece out. So you have to be careful to put it back in. So if I were to put the edges in here, I'm going to look for the green edge that's on the bottom. So this is an edge piece over here. This has to come up to here. But if I turn it like this, I've knocked this edge slash centerpiece out. So in order to make that work, the way that you do a typical supercube scramble or supercube strategy is that you move it out of the way, turn this down, you're dragging the centerpiece with it, and that's really what this edge has become, a centerpiece. Dragging it down, moving it in to match it, and then this is going to come up to here without changing the configuration of that. So that's pretty straightforward. To turn this upside down, all you have to do is a very quick commutator of F, RI, FI, R, brings it over here. Then you do it again. F, RI, FI, R, turns it upside down. That's kind of a quickie thing that you can do. Same thing over here. These have become centerpieces, so we coordinate this in relation to the center. You can't just move it up, you have to move it down, grab it, and then move it up. So if we were to continue with the solve here, you've got this. Let's turn this upside down. Bang, zoom, splat, pow, ugh, clink, clink, clunk. And it's a fairly quick solve. The thing about the circle cube is it's not particularly difficult if you can do supercube strategy. Again, centerpiece here, move this down, turn it in, put it up. It's just the fact that you like to have it as part of a collection if you want a collection complete. So basically we have all of our edges in here, and then you'd go ahead and just continue with the solve. Now the thing about a true circle cube is you don't look at these as edges. If you look at these as centers, then you don't worry about the fact that they're inner edges and matching the inner with the outer. You don't worry about it. Look at them as centers, put them in as centers, and then you're okay. These guys, because of the intimate correlation that they have with the edges over here, you don't even have to worry about these, because when you put these edges in, this will automatically be placed. So what I mean by that is well, we can go ahead and do the corners here. Outer corners, just ignoring these over here. So green, yellow, and red is over here. That's going to be your RIDA, RD. And we can quickly plop these guys in. Turn, turn, turn. And move this in over here. So there's no real reductive process that you have to worry about with much of these pieces. We saw this with a crazy 4x4. Actually, so this is here. We don't worry about these because these are going to be put in as we put the edges in. So here's what I mean by that. Here's an edge that we're going to put in. We're going to move this down to here. Now by doing this algorithm, these centers, as they're stationary, they're fixed, don't move. Because of that, they're centers, and this is the only thing that's going to move. Don't worry about these being out because they can easily be placed back in. But because of this having to go over here, you're going to have this green piece, this green triangle piece that's going to be just below this, which means it'll automatically come over here too. And that algorithm with beginner's method is going to be the UR, UI, RI, UI, FI, U, and F. This is in, and at the same time this is in. So again, we haven't really added to the challenge too much with that. This is going to wind into here. It's not going to affect these guys. Turn, 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 turn. And as predicted, the green one will enter into there as well. This is turned upside down. Not only can you see this turned upside down, but this green is upside down. So that is the basic structure of how these types of puzzles come together, and why it was necessary, if you're going to make something of a challenge, to variate this. Right, Noah?
Right.
That's him in the background, way past his bedtime. Anyway, this is here. This actually turned out pretty easy because these happen to all be flipped right. But I want you to notice something about this too. These are all flipped. If not, you do the F, R, U, R, I, U, I, F, I. These are all correlated here pretty well, but what about these guys? Well, I want to move these in and I'm going to do the algorithm that spins these around. This is where it should be, but these aren't. Now I want you to notice that I've got one that's reduced, the rest aren't. That's how it's always going to be. Either one is reduced and the rest aren't, or they're all reduced. By reduced I mean that the inner and outers are near each other. What I'm really saying is that if I look at these guys as just equivalents of the centers, then I have one edge piece in and three that's out, the way you would have normally with a Rubik's Cube. So that's going to be, if I want to put this right one in, I'm going to do RU, RI, U, R, 2U, RI, not in yet. Eventually they're all going to be in if I keep doing that algorithm. 2U, RI, so you can see all these are in. Then it's just a matter of, now notice also, when I put these in correctly, these are also in. So we've got these centers reduced, and then I just do my RI, DI, RDs to get all of these in. This is where it needs to be, the rest aren't. So we do the algorithm that switches these corners around. UR, UILI, URI, UIL. Not yet, so do it again. Beginner's method. So all these are in. I just have to get this in by doing RI, DI, RD, RI, DI, RD. Turn it again here. This is out, but not for long, because with this technique, it eventually comes in, and without any worries, it's solved. Okay, so you needed to variate this in order to make it more of a challenge. So what the Earth cube is going to do is it's going to make it to where you're going to pull some of these out of its axis. And with some of these, like this center over here, these edges, once they're put in, these inner edges are going to be basically pretty much functioning as centers. And anything that is orbiting one of these center pieces here, these inner edges will act as centers. However, if they find their way into the trap of one of these fixed centers, then these edges will not act as centers, they'll act as edges. So here, if you have it between these two, then it's going to act like edges in the truest sense. It'll move with every rotation of every face. As opposed to here, this won't move here, but it will move over here. This will then become an edge as opposed to a center. So because of that, you're also going to pull it out of the exact association between the edges here, the outer edges, and the inner circle. Notice if I move this, this is always going to, well actually, we'll do this one. This is going to be associated with this piece here. I can't separate it, Nothing I can do that'll separate these. But if I move it here, now this piece, this inner triangle can now be separated from this piece over here. So because of that, as I'm scrambling it, I'm losing the exact association between the outer edges and the inner corners. And that's why when you solve it, you're going to have these not necessarily or not automatically be solved. You're also going to be taking things out of alignment because these always maintain the same position. But that's not so with this puzzle, with the Earth puzzle. If I turn this, I can actually turn them out of alignment. So if I turn this over here, this one doesn't change. This one does. So I'm pulling things variably out of their original conformation and ending up with truly a challenging circle cube solve. Again, this is the Earth variant. You have different variants that have different possible outcomes with that. I have done tutorials on all of them with varying degrees of success in my descriptive abilities. I've done a reboot of the Saturn. I'm going to do this one of Earth because I've had some number of requests to please refine and explain and stop skipping around and stop referring to previous tutorials like the Mercury, because I was building one after another. So I'm just going to take this puzzle as just kind of a random example of what to do should you have picked this one up. I'm going to keep scrambling, and as I'm doing this, I'm pulling it away from the usual configuration, making it a circle cube of the highest challenge. Abracadabra.